Hello everyone, I'm Bright Udu, a group lead of 2.7. Imagine buying a brand new LED, connecting it directly to a battery, and watching it burn out within seconds. How does that happen? Because LED requires a current limiting resistor. Our project, the LED resistor value calculator system, solves this problem by automatically calculating the correct resistor value and power rating using C++. Now, let's see how we plan this solution.
Every successful program begins with a plan. Just as you won't build a house without a blueprint, we can't write our code without an algorithm. Our algorithm guides the program from collecting the user's input, validating them and performing calculations, displaying the results, saving them to a report file, and finally ending the program. This ensured every step followed by a logical sequence.
Once the algorithm was complete, we converted it into pseudocode. Think of pseudocode as the bridge between human thinking and computer programming. It describes the program logic using simple keywords like begin, if, else, and end, making the final C++ implementation much easier and reducing programming errors. Thank you.
I am the Flowchart designer. I transform our algorithm into flowcharts using standard flowchart symbols. Instead of just reading lines of text, anyone can quickly see how the program starts, receives user inputs, validates the values, perform calculations, and displays the output, saves the reports, and then end the program. We use flowcharts because flowcharts helps us visualize the entire system before implementation.
With the design complete, we began coding in C++ using object-oriented programming. We created a class called LED circuit to store all the circuit information. We also divided the program into functions so that each function performs a specific task, such as receiving user inputs, validating data, or displaying results. We used void, bool. Those are a few ones I can mention. This made our code clean, reusable, and very easy to maintain. We are good.
The heart of our program is Ohm's law. For example, if the supply voltage is 5 volts, the LED void voltage is 2 volts, and the desired current is 20 milliamperes, our program automatically calculates a resistor value of 150 ohms. It also calculates the minimum resistor power rating and checks for invalid input, helping users avoid unsafe circuit designs.
After development, we tested the application with different input values. Valid inputs produce accurate calculations, whilst invalid values, such as negative voltage or zero current, were correctly rejected. We also verified that the program warns users whenever the LED or LED currents exceed the recommended limit for a standard LED.
As the GitHub manager, my responsibility was to manage the repository. I created and hosted a repository and invited every team member as a collaborator and ensured everyone submitted their assigned work. This allows us to combine our individual work into an organized project while using the version control to track, update, and record our development process.
As we bring this presentation to a close, I hope we've demonstrated that programming isn't just about coding, but rather it's about solving real-world engineering problems with logic, precision, and innovation. This project represents the successful integration of engineering knowledge and software development to produce a reliable solution. This project has strengthened our technical skills, teamwork, and our appreciation for how technology can transform our ideas into reality. We are Group 2.7. This has been the LED Resistor Value Calculator System. Thank you for your attention.
I'm the documentation lead.